All right, so yeah, it's very different from one side to the other. All right. Also, if you look at the size of the ice particles, what we call the grain size here, notice the largest ones are out here. So the largest chunks are out here, and they get smaller as you go in. Which kind of makes sense because all these particles are running into each other, and every time they run into each other, they break apart. And as they break apart, the smaller particles start to migrate in. The ones that are out here that are larger eventually get hit, and they get smaller and smaller as they fall in. By the time they get to Saturn, there are very small particles raining down on Saturn. All right. We also can see cool things like here's one of those smaller gaps, not caused by the gravitational resonance, but it's caused by a bigger chunk. Now you can call that a bigger chunk of moon, you could if you want, but you see as it orbits through the rings, it clears a hole. Because all the ring particles will either get sucked onto it or they'll get pushed out. Notice also this wave it creates. What that wave tells us is this is not round. It's actually an elongated moon, and it's rotating like this. Then as it spins, because it's elongated, as it spins, it's going to make the particles wave in and out. You can see it was closer up here because the bottom wasn't affected, but now it's affected down here. So it went a little bit up here, and then it's coming back down here. It's going in an elliptical orbit. It's not exactly in the center of that gap. All right, so what they found once they got to Jupiter, to Saturn, I don't know why I keep saying Jupiter, is that there were many more rings. They found that there was another ring inside here that goes all the way to Saturn. Very thin, hard to see ring. You can only see it when you get there. They call that the D ring. Then they found a ring way out here, significantly further away than the other rings. It's kind of a thin ring, but they call this the E ring because they just go in discovery orbit. Then they found the F ring. Was right here. It's a very thin, narrow ring, just outside the A ring. This is called the F ring, right here. Or I guess they're all rings, so that's the F ring. That's what this is a picture of. And the F ring is very interesting because it's all twisted like that, and they're like, wow, how do you get a twisted ring like that? But before I go on and talk about that, I want to add the last ring they found. They found another one they called the G ring in here. And so they found another ring between the F ring and the E ring. This is the G ring. So it's a little confusing because it goes E, G, F, A, B, C, D. But that goes by discovery, obviously, not by closeness to the planet. Now the F ring is this narrow, thin, twisted up ring, and they're like, oh, how could that occur? Well, the only way you can have a narrow ring like this, because ring particles are going to slowly try to dissipate over time. As they bounce into each other, they're going to dissipate. The only way you can keep that from happening is if you have a moon on the inside and the outside of it. And we have a name for these. We call these shepherd moons. Shepherd moons? Did I spell that right? Shepherd, I think that's an E. Shepherd moons? I'm not sure I spelled that right. But you got the idea. They're herding, just like a shepherd herds the sheep. They're herding the ring between them. If you see a thin ring around any planet that's been there, it looks for a long time, the only way it can exist is you have to have shepherd moons. You have to have moons on one side or the other of it that keep the ring particles in between them. So as they start to wander, these moons bring them back and just hold them in that position around a thing. So they went looking for them, and sure enough, here they are. Here are the shepherd moons. Here's the F ring going right between them. This is an artist's conception of what it would look like from Enceladus. This is one of the moons we'll talk about later. If you had a colony on a moon, Saturn would be a spectacular place. Can you imagine living where you have this huge ring plane and Saturn in the distance as your view? And all these are tidally locked, so Saturn would always be in the same spot all the time in your sky. So you could have a spectacular like hotel room with this giant window looking out on Saturn there, and it's always going to be there. It's not like it's going to change over time. It'll always be exactly in the same spot. So that's not a true picture, that's an artist rendering of it. We also see things called spokes. These are particles of dark material. See that? That gets deposited on the rings. Especially it shows up on the B ring because the B ring is the brightest. It gets deposited on all of it. It shows up best on the B ring. And the interesting thing about this was actually discovered by amateurs first back in the 70s and said, hey, we're seeing dark stuff on the rings. And then NASA scientists said, no, you're seeing things, all right, back then. And then sure enough, when the spacecraft went there, they go, yeah, there's spokes there. And they're like, oh, I guess those amateurs were right. What happens is, Saturn has a very extensive magnetic field. Not surprised when it has that liquid metallic hydrogen layer rotating around fast. This dark material, think of it like soot, like carbon stuff, all right, like the soot or ashes you would get. Well, that's charged particles, and it's out in space. It gets caught in the magnetic field, and it starts to bounce around the magnetic field. And normally it would just be trapped in the magnetic field around Saturn. But since it has rings, the magnetic field goes right to the rings. Those particles, boom, hit the rings, and they stick on the rings. Essentially, you're covering the ice with this dark carbon material. That's what the spokes are. Over time, it's going to make them darker and darker, and the rings are going to get harder and harder to see. The ice will still be there, but it'll be covered in soot. It'll be covered in this dark material. All right, that's all I have about Saturn. One of the neatest planets to look at in the sky.